Today we're going to do another video. We're demonstrating using WasmEdge, the WebAssembly runtime, and also the distributed application runtime called Dapr. We're just talking about having the best of both worlds when it comes to using a containerized solution for deploying distributed applications. Dapr is an open source framework for building microservices. WebAssembly VMs such as WasmEdge provide high performance and secure runtimes for microservice applications. In Dapr, each building block that you use is independent, and therefore you can use one, some, or all of them in your application. In this scenario, the request data is being passed to the WebAssembly runtime, WasmEdge. So why would we do this? Well, this is because WebAssembly programs can run safely and in isolation and offer extremely high performance, as fast as machine native libraries, and in addition, with significantly reduced load on system resources. So talk about having the best of both worlds. Both Dapr and WasmEdge are perfect for cloud and edge applications. So today we're going to do a hands-on demonstration. We're going to create an application which does image processing and also object classification. Okay, to carry out these demonstrations, we're going to refer to an article. If you go to infoq.com, you can see this link up here. You can pause the video and visit that URL, and depending on where you're watching this, you could just check the descriptions for a clickable URL. So this is a fantastic article. It goes through a few of the key points, and if you scroll down here to below figure 2, you'll see some commands to actually build the classify and grayscale WebAssembly functions and then deploy them. So we're going to go ahead and carry out this demonstration here, which is just below figure 2 in this article. Now, before we do that, we have to go ahead and install WasmEdge. Now, thankfully, this is really simple. You go to github.com and WasmEdge, and if you find this install document here, you'll see a single command, and you simply paste that into your terminal, and that will go ahead and automatically install WasmEdge. Now, once that's installed, to save you logging out and logging back in again, you just grab this command here and just run that in your terminal as well. And that makes everything immediately available for use. Okay, so the next thing we have to do is download Dapr. So if we go to docs.dapr.io, just click on Get Started here. And then we install the Dapr command line interface. All you need to do is simply grab this single command and paste that into your terminal. Okay, so from there, we can type in Dapr into the command line and just confirm the installation. Now, another thing we have to do is initialize Dapper, which is very simple. If you scroll down here, click on this Initialize Dapper, you'll see that there's a Dapr space init function, DAPR space init, and that'll go ahead and initialize Dapper for our use today. Perfect. Okay, so heading back to this article here, we're going to carry out these steps here as shown under figure 2. Now, just in the sentence here, it says you can follow the instructions in the README file. We're going to actually follow these straight from the article here, but the README file actually links off to the second state repository on GitHub. And this demo is all encapsulated in this repository called Dapr-Wasm. So grab the demonstration code. So we git clone that. So the first thing we do, obviously, after changing into the Dapr-Wasm directory, once it's cloned, is to go ahead and cd into the functions and then grayscale directory and then start building this function, and we're going to move through these one at a time. Okay, so it looks like that's finished. So we cd Dapr-Wasm. All right, and as per this, we go cd functions grayscale. All right, and then we /build. Okay, so that's the grayscale function built. So now we're going to head back up and we're going to go into functions classify. And now we're going to do the TensorFlow classification build. All right, perfect. And then from there, /build.sh. Now the next component here is we're actually going to build and start a web service for this application's user interface. We've got a CD backup and then into a directory called web-port. All right, and once we're in that, we're going to actually use Go to build this. So we type Go build. All right, that's finished. Now to run this, we use /run_web.sh. Okay, so now we've got a user interface for the application running on port 8080. We're going to access that on localhost in just a minute. But before then, we've got these functions built up here. So we've got the grayscale function, which is image processing, and then we've got this classify function, which is a TensorFlow function. What we're going to do is actually create microservices for those functions. So to do that, we're now going to go into the cd image-api-rs directory. So I'll just grab a new terminal here for this. And once we're in that directory, we're going to cargo build that. All right, so once that's finished, we're actually going to go ahead and start that microservice. So essentially, it's now going to form the function as a microservice in response to any requests coming in from the web service, which is essentially the application's user interface. So we just simply go ./run_api_rs. Okay, microservice is running. So the last microservice we're doing here is the TensorFlow-based image classification. So we're going to go into the image API Go directory now. Again, grab a new terminal for this. Okay, so for this one, we're going to do this slightly different build here. We're actually using Go. So Go build -- tags, TensorFlow image. And from there, we're going to ./run_api_go.sh. Okay, so that's that microservice running as well. If we go to our browser now, we'll be able to see the application's user interface, where we can action the microservices, which we'll call the functions. Okay, so here we're just going to use a random photo. We're just going to go to Wikipedia and grab a picture of a hot dog. So we go here, select the photo, and we want to go to downloads and the hot dog picture, open that up, and we're going to classify this image. It is very likely a hot dog in the picture. All right. Okay, let's try something completely different. Let's try sports car down here. Okay, so what about this Ferrari 458 Spider? Download that to our images. Okay, once that's done, we select the photo. So the Ferrari 458 Spider, open that up and classify. It's very likely a sports car in the picture. Excellent. Now the other function that we had, we can call from here. So this was the grayscale. So this will turn that color photo into a grayscale image. Perfect. Okay, that's it for this demonstration. If you'd like to give this a go, head over to this article, and obviously you've got the Dapr-Wasm repository, which is essentially this demonstration with all its commands and all the background information that you require. Feel free to visit WasmEdge.org and also secondstate.io. There's plenty of information there, and if you've got any questions, please don't hesitate to reach out on GitHub. Either Second State or WasmEdge GitHub organizations would be great. Thanks so much for watching, and we'll see you next time.